we try to prove this inequality. Of course, A, B, C, D are real numbers. Why don't you pause and give it a try? I do find an online solution to this. They use different order of A, B, C, D, but that doesn't really matter. So in order to prove this, you square it, you cancel certain terms, and then is equivalent to prove this particular solutions by canceling common terms, and you can further cancel 2 here, and you square it again, right? And then you expand it out, and on both sides you're going to cancel terms again, right? Now here, of course, finally this is going to be obvious. This is the whole thing is x squared plus y squared greater or equal to 2xy. All right, so a reasonable solution. However, there is a better solution. All right, so if you want, this is another chance to pause and figure out what you would do. If you have not seen this before, maybe you're gonna come to an aha moment. All right, do that, and when you're ready, let's go. Now, I revealed the solution is related to complex numbers. Of course, there is an important property here for two complex numbers, z and w, and that's notation is going to be modulus, right? Modulus of a complex number. Yeah, so there is a famous, what is called the triangle inequality for complex number. The modulus, the addition of the two, is going to be no greater than the sum of individual modulus. Alright, so what is the proof? This is called triangle inequality because the geometric interpretation of z and w is going to be z plus w. In this triangle here, individual modulus is two sides of the triangle. The sum of two sides in a triangle is going to be greater or equal to the equality holds when z and w is in the same direction, right? So on the same straight line. So here we have the proof, right? This is basic property for the modulus of complex number. And if you know that, then come back to our proof. The idea is that a, b, and c, d could be a complex number, right? So if it's a plus bi, that equal to z, and c plus di, that equal to w, where I is the imaginary unit. So then the sum would be a plus c, the real part, and the imaginary part is going to be b plus di, right? Now we can just plug in the inequality that we just learned, the triangle inequality, and the definition of the modulus here is going to be square root of a squared plus b squared. If you plug in the formula for the modulus, you get exactly this inequality. That's the proof. Simple and elegant. Originally, I would like to put this as my thumbnail image. However, I don't want to reveal the hint here, complex number, right? So that's intentional. But hope you enjoyed the video, and this is part of what is called Mastering Complex Number video series. We're going to have some other interesting problem related with complex number. We have some simpler problem earlier on. Do check it out. So do like, share, and subscribe to the channel.